So over weekend, I will see well, what can I do? I just look at the quizzes, right? If you took quizzes, I think everybody got maximum. So if you took quizzes, you will get a perfect grade. And if you did not take the quizzes yet, well, take them. They all in the recordings of these lectures. So I email you the recordings. So check your student email, because that's the only way that we can communicate using student email, right? So you should check it periodically. And if you miss the lecture, then you should watch it. And at the end of some lectures, not all of them are quizzes, so just take them and email me the answer. And some people do that. They have every time, but like 5, 6, 7 students after the quiz email me the answer, and they get a full credit. That's fine, as long as they follow the material. That's the point of the quiz. So anyways, let me start with the quiz we had last time. I believe it was exercise 30, right? So this exercise had y squared over 16, which is 4 squared. Please correct me if I'm wrong. I could be wrong, but I think it's 30 divided by, yeah, email me the answer. That's all you have to do. I need answer. So divided by 2 squared under x squared, and this is equal to 1. So what can you do to produce this hyperbola? Hyperbola is because of negative sign, right? If it's a plus, then it's ellipse, but we have hyperbola. So there'll be a box here with a center at the origin, and you go by 2 units to the left and to the right, because that's your a. It's always under x, so a squared, so a is going to be 2, and your b is going to be under y, so there's 4, so a is 2, y is 4, that's b. And the key idea is what to do to get this hyperbola, those branches of hyperbola. And the answer is, since x is negative, then we need to put this on the top and the bottom. I say, so I have to memorize all that? Well, we can make sense of this, of course. Let's do that. So y, this is going to be on the top and the bottom of the box. So let's say this is x-axis and this is y-axis, right? It's always horizontal is x-axis. So I'm going to get a nice graph here, and that be going here and there, and same on the bottom. So the answer was the top and the bottom. So it looks like we just can test the point. For example, let's say if we wonder, maybe it's on the right and on the left, if this point with coordinates 2 for x, isn't it? Because we start at 0 and we'll go 2 units, and then 0 for y because we are on the axis. So it's point 2 for x and 0 for y going to work in this equation. That's what we're graphing. So y is 0. So I'm gonna test and see is 0 squared over 4 squared minus x is 2. So I'm plugging this right in the formula. So it's 2 squared over denominator, which is also 2 squared, is going to be equal to number 1. And the answer is no, because it's a negative 1. So it's not equal to positive. So 0.20 is not working. So you can test and see if the other point, which is 0 for x and 4 for y, is going to be working. So let's test that one. So for y, I use 4 squared divided by 4 squared, the same thing, minus. And for x, we use 0, right? Because again, this is the point that we're testing. And equation for y, I put 4, for x, I put 0. So you always plug it in the equation you're trying to graph, because that's what we are doing here. We are graphing. And notice that this cancels because that's a 0. So 4 over 4 squared will be 16 over 16, which is 1. And the answer is yes, it checks. So that point works. So technically, you can do the same thing to test if it's upper or left and right hyperbola for any of these exercises, because the point must test, must check. So the points you can always locate here in the exercises, in the pictures. Or after you made a picture, you can test those points. So let me do this once again with completing of squares. I already promised you that this be the exercise that we are going to see on our midterm exam. So either ellipse or hyperbola, I will ask you to graph and, well, I guess, show me work. Because I know there are some special computer systems that graph just about anything, but I will be asking you to go through the work to this completing of squares to give you a full credit. Because if you're not going to show work, you will get some credit, but not the full credit. That's the idea. So let me try one. Let's say we probably did 55 last time because it looks really attractive. So I'm going to do 58. And let me share a screen with you, because these exercises, they take some room. And that's why you don't want to save on paper when you do these problems, because when you start to save paper, there's a chance to make a mistake. And you don't want to make a mistake. So you want to get plenty of paper, not to save paper. And if you don't have enough paper, you can always stop by at the library in the college and get paper. So they have lots of scrap paper there. So you can always ask them. This is something they never gonna deny you with, the scrap paper. And you can also do your homework there, right? You can also even take the test in there, because I will be expecting you to make a picture of your work and email it to me, so you can get help in the library. They will definitely scan and help you to email me your work if you never did it before. And that's to those people that didn't know that this class does not meet on campus. So no worries, it's fine. You can be online all the time and anywhere you like. Any place you want to be is fine. I don't have control over it when you're taking your tests. And you can always get help if you need some help in terms of scanning and submitting this. And that's why I recommend you to be on campus if you've never done it before, but it is really up to you. So anyways, here's the equation. And I would say that this is hyperbola right away because of negative sign with y squared. So this is equation of hyperbola. And then I see this x terms that appear twice, as well as y terms that appear twice. So I'm going to need to complete squares. So I need to prepare my equation for it. I'm going to put x terms together, and also I want to have a clean x squared, so factor out 2 from here and from 4x, so that'd be plus 2x. You can always check this out, so you can always bring this 2 back, be 2x squared, and 2 times 2x is that 4x back. Leave some room and then put a minus, because we want to also have a clean y squared, no negative in front. to be able to complete our square. And then we change the sign with this 4y, so it'll be negative 4y. So that way I prepared to complete square. And again, for the exam, I will give you plenty of time for this. If you need an hour to do this, fine. I say, Alex, can I get 10 hours for that? Fine, 10 hours. I think if you be doing it, not just leave the place and never come back, well, 10 hours will be more than enough time to double check, to triple check, to take a nap and check it again, and then to make sure you scan it. And if it doesn't work, no panic, go on campus. When you say, Alex, I tried to go on campus, it was already too late. Okay, go the next day on campus. It's fine. I'm not gonna really rush you into doing the exams quickly. And I don't give any particular time frame for it. So I give the whole day. So that'd be, I think, fair. So 2 is what I need to divide by 2 to get 1. So it'll be 1 squared. And then I subtract the exact same number 1. And then a half of 4, which is going to be 2, right? And I have to put squared. It needs to be always squared. So 2 squared is 4. So I add and subtract. So we're almost done. Standard procedure. So we get this x, the first term in the parentheses, and the last term is 1. So it's x plus 1 squared. And same for y's. So y squared is always given me y. And then there is a minus sign because we have negative inside the parentheses with 4y. And then 2 squared, so we get a 2. And the whole thing is squared. I know it's pretty straightforward and annoying and boring when I do this. Try to do this yourself over weekend. I think it'd be very good practice because this way you might encounter something that you are missing. And if you're missing something, then it's a good idea to fix it before the exam, not after the exam. I do give my students to fix it even if they didn't like the result on the exam, so you can always do it after exam. But usually it's smart idea to learn things before the exam. But again, I think I already mentioned I don't really care if you learn it before or after the exam, and that's why I always give you a chance to fix results of your midterm as well as final. But for the final, it's a little different because we don't have that much time. We have limit because final is given on the last week of class, so you have just a couple of days. So you don't want to be over relaxed. So anyways, what I'm doing now is I distribute this 2. So I get rid of this big green parentheses and I distribute that negative analogously. So it'd be y minus 2 squared and then plus 4. And also there is minus 4 that I'm going to cancel right away with plus 4. It's nice. And then I'm going to bring the 2 over to the other side. That minus 2 that should not be here with me. It has to go to the right side as a plus 2. So now it's standard. Now we need to produce number 1 on the right side. It's the same for all exercises. So we should get used to this procedure. I say, Alex, I will learn it when we get closer to the midterm. Well, when we get closer to the midterm, the time passes by and you might forget everything completely. It's going to be another 3 weeks or so. That's why try it now, try it over weekend, try it today. It'd be a good practice. So x plus 1 squared is left here over what? Well, it's just 1, so I can put 1 squared. Minus, and then the other one is over 2. So I put this trick, square root 2 squared. So square root and squared disappear, right? And we just get a 2, but we need this number squared. What number? Well, denominator, this is my b because it's under y. and this is my A because it's under X. I know in the textbook they have a little bit different way. I think, confusing people. They just start as always with A, and then sometimes they switch it with B because if B is bigger or A is bigger, so here they would have probably used this as A, but that's at the end of the day giving you the same thing, but with more sophistication. So I would not advise you do it like that. I'm trying to show you the shortest and most efficient way to do the problem, because the shorter it is, the less chance one has to make mistake, and you don't want to make mistakes. So center is going to be a pair -1 and +2, and the A and B are here, so we now gonna make a picture. -1 +2 somewhere here on the left side. And then I'm gonna put the A, which is 1. So we're gonna touch our axis because it's -1, so just 1 unit away, right? So A goes also here. And then B is √2, which is about 1.4. So it's not reaching my x-axis. So it's a little low. Okay. So I'm gonna now produce a rectangle because I need its diagonals. If that be ellipse, I would have produced ellipse right away. But we need a little preparation for this hyperbola picture. So this one, and this is the other one. And then we're gonna need to put it on the top and the bottom, or on the left and the right. Well, x is positive, right? It's gonna be on the left and on the right. Say, Alex, again, how do I know this? I forgot. I do forget things. Well, you can get a piece of paper, scrap a formula sheet, and write top bottom when x is negative, x squared negative, x squared positive, left and right. I think it's simple. Or if you don't want to do that, you can test the point. So which point makes more sense for me to test? And I would say the point that is here, which is sitting on the y-axis, looks like. This is going to be pair 0 for x and 2 for y. Is on the y-axis. We have number 2. So x and y, I plug into where? Well, I would advise you to plug into this equation, because this way you will see the result right away. Because over there, it might be a little bit more algebra, but it doesn't matter. It has to check anyways, since your graph is passing through it. So when you plug in 0 for x and 2 for y, you should get the true statement. So let's see that. 0 plus 1 squared. Instead of x, I put 0 divided by 1 squared, minus, instead of y, I put 2. So that would be 2 minus 2. Let's say that cancels. Yes, it has to, because we have the actual negative sign with this term, but the result must be positive. So this is 0 squared, it's 0. So you subtract nothing from 1 over 1, which is indeed 1. So it doesn't check. So you can always check. In fact, if it's really fractional, if your center is not as nice, then you can just plug it in the original equation. It has to also check. If you want, I can do that. Just give you more confidence. 0 here, 0 here. I like zeros because they canceled. They disappeared. So all we're left with is a negative 2 squared instead of y, put 2 plus 4 times 2, right? And minus 4. So is it gonna really work? Well, it has to. Otherwise, this is not the correct point. Otherwise, the point is not on your graph. So it must check. So this is -4, 8, -4. Yes, it is. 0. Yes, it is. Checks. But that's it. So have confidence in this. And if not, look at the stuff we did again and again, and this is the way to go. So I think I'm gonna do another exercise because the section is tedious and I never did exercise with fractions. So I want to get something nasty. I want to get fractions, but they're not nasty. They are our little friends. So it's good to realize that nothing to be afraid of fractions. You could use a calculator, or you can turn them to decimals if you like. So it is up to you, really. I'm just trying to find the problem with numbers that are not gonna be nice. In other words, that don't have even coefficients with these x and y's. Do they have anything without even coefficients? I think in this section, everything is nice and even. Maybe I'll go for ellipse. I think I saw some problems to complete square in that section, and I left them for now because I thought that it'd be better that we do this at the end. So today is Friday. I'm not going to give you a quiz, but instead I will do another exercise to complete the square, but now on ellipse and using the case when we have to deal with fractions. So where are the fractions? Four fractions. But I saw an exercise with fractions. Let me try to find it. Just can't get one right away, which is disappointing. I can make one up. Let me do one like that. So let me try to produce an exercise for you because that's usually the case. I'm sure they are somewhere. Just don't want to waste time browsing through all these exercises. So let me go back to share board. And I'm gonna go to the next page of it. So let me get something with fractions. Let's say x squared minus x plus, if I put plus y squared, that'd be ellipse. So let's say plus 2y squared minus, let's get something nasty, 3y is equal to plus, let's say put number 12 is equal to 1. I hope, well, 0, usually they have 0. I hope that will work because I need to make sure that this is possible. Maybe to make sure that it is possible, I'll make a hyperbola. I'll make it like that because sometimes it may be negative, so I don't want to start messing. But with hyperbola, I think it'd be either left, right, or top, bottom, so it doesn't matter. Okay, so here's the example that I again have to complete the square. So I'm going to need to prepare my x terms separately, and then y terms are going to be not very attractive because we have to take out -2 from these y terms. So the sign will change to the minus. So you take out negative, comes plus, and then you divide by 3. So it'll be 3 over 2y. I think if you took the class with me for college algebra, we did lots of completing squares when we had this parabola-like stuff. And now the other part with x is also added. So it's like one step beyond. But anyways, let's take half of this term, and this is 1x. So I'm going to have to take half divided by 2. Or you can put 0.5. But the idea, you put 2 in denominator, square this thing, And then you subtract exact same thing. It's 1/4. You see, 1 squared, 2 squared. 2 squared is 4 in denominator. So fractions came in. Okay, what else? Well, here comes 3/2 that I need to divide by 2. So I need to put extra 2 in denominator. So it'll be 2 and another 2 with it, so it's 4. You see, I double my denominator because I cannot divide it nicely. So extra 2 always goes to denominator when we divide by 2. So it'll be 3/4. And again, I need to square this thing. And then subtract the square of it. So 3 squared is 9. 4 squared is 16. And now it makes me feel real good. I say, you like the way it looks? No, I already have squares completed. That's why. So x is my first term minus, and 1/2 is my second term squared. So first and last, it doesn't matter. They're fractions or whatever. So just completed square. That's why I feel good. So y. So y squared gives me y. And the last is 3/4. Okay, I write it the way it is. 3/4 squared. And there is a plus in between us. Everything is positive. Great, let's copy the rest. It's a -1/4. There is a -2 in a big red parentheses. And there is still -9/16. You see, it's good to have plenty of room. That way you're never gonna make a mistake. So it's another, I guess, trick in doing well in math classes. Have always enough paper. So x minus 1/2 squared, and then -1/4. Well, I'll leave it for now because there'll be another one coming to it, another friend. So there'll be 2 that I distribute over this red parentheses. Y plus 3/4 squared, and then minus, and then when you say you need to multiply these fractions, yeah. So if you don't see right away the answer, put 2 times -9/16. So this way you will be able to produce 8s. And then plus 12. So now what? Well, now I need to get all of this stuff to the other side, all of these little fractions. So they will be a quarter with a plus sign. I change signs. And 9/8 and -12. Right? So how can I put them all together? Well, you can use either a calculator, or if you don't want to mess with those decimals, you can keep working with denominators. The largest denominator I see here is what? 8, right? So they all be turned to the 8s. So how many 8s? Well, this needs to be multiplied, divided by 2, so nothing is changed. And that one multiplied and divided by 8. So 12 times 8 is 96. So it's -96. And then there is a 2 and 9, which is 11 minus 96. So this is going to be actually -85. Okay. 85 over 8. See, I made up exercise that is really unpleasant, but it doesn't matter to us because all we have to do is just divide by this same exact whatever it is. 85/8, fine. Divide by it. Don't just look at it. Divide by it. So that way the signs will change. That's fine. The signs will change. I just went overexcited with having plenty of room, and that way I don't have much room to continue with. But the good news is that we produced 1. And now we need to flip, right? This 85/8. Actually, not to flip it, but I was not careful. Don't flip it because we need squares in denominator. Just need to write it as a square. You see, but it's negative, Alex. How do you write the square? Very simple. Put a minus out. Like that. And then your x minus 1/2, or if you like 0.5 to the second power, will be divided by square root from 85/8 squared. Where can I write this? How to fit this in, that's the issue. But right, a square root from this fraction square. See, the minus I put in front of the entire fraction. And then the other sign, I should have been careful. This is minus, and this is minus. I did it on purpose. So one be minus, the other be plus, so it'd be hyperbole. So I wasn't careful. See, I lost the minus. I put a plus instead. So now there would be two negatives, so it'd be positive. That was the whole point of working on hyperbole. So now the question is what to do with 2? How can I take care of 8? Well, if you have 2, let me write it here, utilize this rule a little bit. So if that's 2, so minus is already gone, so I'm not going to worry about the sign. So just put 3/4. In other words, I have to be careful. It was 3/4. You see this quarters. 3/3, 3/4. Okay, so y minus y plus 3/4 squared. Now I want to simplify this thing by bringing the 2 down. So how can I bring that number 2 down? Well, I need to multiply by 1/2. To cancel the 2, we'll multiply by 1/2, but we must do the same thing and on the top and on the bottom of our fraction. So this way 2 disappears, but goes all the way down to denominator, right? So this way we get 16ths. Okay, so the other piece again. So you have plus y plus 3/4 in the parentheses, right? Squared. And then there'd be 85/16. And again, it's a square root and squared. 85/16. See, I had so much paper, I didn't use it smart way. I don't want to go to another page, but when you on your own, you can definitely do whatever, so you can just get another page. And this way you enjoy having plenty of room, right? So anyways, we're almost done. I'm just trying to stick this stuff in here. So we have a square root from this denominator, which is 85/16. So I can square root from 85/16. And squared, square root and squared. So it involved with algebra, but the same tricks for all of the exercises. So I have to get the center of my hyperbola, which is 1/2 for x, one that we subtract. So change signs. Minus, put plus. This is plus 3/4, so I put minus. Always change signs. That's my center. And now under x, I have my a. So a is that square root 85/8. It's about what? 9 and something, so close to 3. Close to 3. You can put in a calculator and get the answer. Whatever it is exactly. So it's about 3. That's for A. And B is going to be a square root from denominator I can extract. So it'll be square root 85/4. I see. If it's over 16, bigger denominator, so the number is smaller. Yeah, it's like twice smaller or so. So it'll be like 1.78, something like that. And once you have the center and A and B, then you can graph hyperbola. And just to finish up, x is negative. In here, it's Alex, x used to be positive, your y used to be negative. Well, in order to produce 1, I had to turn x into negative. So it'll be left, right, or top, bottom. Top, bottom, right? Just like you have on the quiz last time. So anyways, as promised, I'm not giving you a quiz today. If you be able to follow through this exercise, and you can do any of them in this particular section.
Professor,
Yes,
just one little question. How do you get 9/16?
9 over 16. So when I produce 9, 9, where's 9 over 16?
It's about
Look here, 3/4. I see. So 3/4 here. 3/4 squared, right? So how do you square this fraction 3/4? You square numerator, you get 9. You square denominator, you get 16. So you added this 9/16, then you also have to subtract it. So I keep 3/4, so it's nicely visible, but 9/16 will be further utilized in the next step, so I don't write it as 3/4, just 9/16. So we add 9/16 and we subtract 9/16. I'm glad that you're not afraid of fractions. That's the way to go. In fact, again, if you're going to take the calculus classes, there'll be lots of steps that involve fractions that people don't even notice, and no instructor is even going to bother explaining this. They say, oh, that's arithmetic, you must know it. Well, no, I think that's where usually mistakes are hiding in this arithmetic. So it's a very good idea to actually get pen and paper and work it out. Or as I said, you could just turn this all into decimals. So you get a half, here will be 0.25, and that way you may get a better feeling for this. It doesn't matter to me because I know that fractions and decimals are the same. So it makes no difference. Whichever you feel more comfortable to work with. But I think with fractions, it's more intuitive because it's more visible of what you are actually doing in the exercises. We're done with the chapter. How about that? The story that they have in the next, and actually last 2 sections. I go back to the textbook, is dealing with rotating those figures like ellipses or hyperbolas, and that's being done by actually working in trigonometrical environment. And with this environment, we don't do that because it's one step into calculus 4, but you probably never heard of calculus 4 because they canceled it a long time ago, probably about 15 years ago or so. So that's why we don't need to worry about the rotation of coordinate axis. I think if you become math major, you will see it. There is a class that I don't think it's called even this calculus 4 because it's not common. Even for engineers, it should have been something useful, but I guess they decided not to worry about it. So this rotation of axis, we don't worry about at all. And then we're going to move next week, to the next chapter of this textbook. So see, they show how they could rotate those axes. I think this is exciting stuff, but it takes time. That's why these classes, they used to be all 5 units, and then they started to cut on those number of units. So now they have 3 units, and that's why there's no way you can actually fit the material in it. And it gets very technical. The formula wise, it gets pretty nasty actually. And that's why I'm trying to cut the material for you and present it in the most efficient manner, because as I said, if you start reading this beginning of sections, you will see a lot of formulas, much more than I'm showing you. So I'm trying to show you these really core, because yeah, you could add as much material as you want. So, but I don't think I'm gonna do this here. So there are various ways. There's a set of so-called polar coordinates, and you probably encountered it if you took trigonometry. It's really exciting, a totally different way to describe things. And again, if you did not take trigonometry, maybe eventually you will take it before getting into the calculus. I think we heavily utilize it in the calculus 2 class. So the next chapter will be completely different. It deals with systems of equations, and that's something that you probably already saw previously. So system of equations is just a standard material of our intermediate algebra classes. But we'll go over this, and then we'll add 3 variables. So there'll be X, Y, and Z variable letters. So there'll be a little bit farther, and the problems get a little bit more tedious, but there's nothing really special about them. Again, all you're gonna need is more paper to put the exercise on, because otherwise it's not gonna fit and you might start making mistakes. So I would say preparation for next week will be just grab somewhere plenty of paper. And at this stage, I guess I'm gonna stop and not to give you a quiz. So have a good weekend. You deserve to relax a little bit. And if someone forgot to send me a quiz answer, send it to me, email it to me, because I do read my email. And if anything bothers you, anything I'm missing or whatever you want to ask, just email me. I always read my email. That's actually the only way to communicate. And I'll do my best to reply right away when I see it. Okay. So I'm gonna stop recording and have a good weekend.